Hello, my dear friends, and here we are starting our class for the Physics GCSE EDEXCEL, and we are here to access, learn, and achieve. So today we are going to start with the topic of understanding motion, and the first topic which we are taking here, it has been scalars and vectors. So what we are going to do in today's class, we'll understand what is the basic idea, what we mean by scalars, what we mean by vectors. Then we talk about the difference between the scalars and the vectors. We'll compare the quantities which are being categorized as scalar and the quantities which are being categorized as vector. And then we'll end our session with a worked example. So let's just start with the scalars and vectors now. So the first thing that comes up here, that is what is scalar. First of all, we must understand what is a quantity. Quantity that can be measured. That can be measured. Okay. So a quantity is a scalar which has only magnitude. Only magnitude, and it does not involve any direction. It does not involve any direction. Now the thing comes up here that what I mean by magnitude. If I'll say 17 meters, so there are two things, 17 and meter. We know that meter is a unit. 17 is a number. So what could be called as a magnitude? Shall I call 17 as a magnitude, meter as a magnitude, or as a whole 17 meter as a magnitude? Please do drop down your answer in the comment section that what you understand by the magnitude. And now I'll answer this question that 17 meter itself is a magnitude. Magnitude is not only number, magnitude is not only unit. 17 meter is the magnitude. Now, when I talk about the numbers here, so what does this numbers refers? This number simply refers that I have to repeat meter by how many times? 17 times to get the magnitude of that quantity. Okay, for an example, let's just think of this way that you have a height of 163 centimeters. To measure your height, what I have to do? I have to repeat 1 centimeter. How many times? 163 times. Understood? So that is being taken as your magnitude. Okay. Now, what are the different examples of the scalars? We'll talk about the speed, the time, then there is a distance, then there is a length, then we talk about pressure, temperature. You might not be able to understand pressure and temperature, what it is. In the coming classes, we'll discuss what we mean by the pressure and temperature. Now, let's just talk about the next quantity, which is being taken as a vector quantity. Now, do you think that only taking up the magnitude will describe a quantity? No, completely. You want to know the direction. Suppose you are riding a bike and you are moving in this direction. How would I know your position if I don't know your direction? I have to get your direction to mention your position after a certain time. Okay, after 5 seconds or after 10 seconds. So those quantities are being categorized as vectors. What are vectors? Vectors which have both magnitude as well as direction, which has both magnitude as well as direction. For an example, here a car moving in north direction covers a distance of 3 kilometers in 5 seconds. So here it is giving us 3 kilometers in 5 seconds. 3 kilometer is the magnitude of the distance. 5 seconds is the magnitude of the time. And here, when I mentioned north, so I specified the direction. Okay. So if I want to calculate the speed, I get how much distance the car has traveled? 3 kilometers. Correct? In how much time? 5 seconds. for now, I am taking here 3 kilometer, the 3 kilometer per second. Okay. So this is our speed, the rate at which the car is moving. But in which direction? North. So when I add the direction to this value, then it becomes a vector quantity. And speed is not a vector quantity. The vector quantity is velocity. Okay. So here, what are vectors? Vectors have both magnitude as well as direction. Now, what are the examples? We'll discuss these examples in detail, the terms which are being mentioned here, like the acceleration and displacement in detail. So here, acceleration, displacement, your force is a vector quantity. Okay. Then weight is a vector quantity. Okay. Then velocity is a vector quantity, etc. There are a number of the vector quantities. Okay. I hope we are clear with the vector quantities. Now, how do you represent a vector? Because vector has a direction. So you represent it by an arrow. Okay. With an arrowhead. The length of the arrow represents the magnitude. Correct? And this arrowhead represents the direction. And this arrowhead represents the direction. Okay. Now, here, there is a convention that right sides are taken as positive, left sides are taken as negative, up direction positive, down direction as negative. So, if I draw a vector, let's just see, which has been moving in this direction. Suppose I am representing the motion of a car which is traveling in east direction. So, here is the arrow. Okay. And it is towards the right. So I take it as positive. Okay. So I have taken it as positive. So if I represent the speed as 5 kilometers per second in east direction, so it is plus 5 kilometers per second in east. If the same car is moving in the west direction, what is west? West is opposite to east. Because you have taken east as positive, so your west would be taken as negative. So it would be minus 5 kilometers per second. So here we have written that arrow represents direction. The arrowhead represents the direction. That's how you represent a vector. I hope I'm clear with the representation of a vector. Now, then we come up, what are the differences? See, when you talk about the certain quantities, it is important that you understand what are the differences between the two. For an example, if I talk about the scalars and vectors, scalars have only magnitude, vectors have magnitudes and direction. What are the examples of scalars? Speed, time, vectors are force, displacement, and these are just not only these examples. There is a wide list of the examples of the quantities which could be considered as scalars and which could be considered as vectors. Now, do understand this difference that when you talk about the addition, see, when you have quantities, you perform certain algebraic operations. For an example, addition, subtraction, multiplication, division. So, when you work with the numbers, these are the algebraic operations, and scalar quantities work well with these algebraic operations. But when you want to work with the vectors, vectors are different. Likewise, the vector addition is different. It has a certain rule which you will be following, the vector addition. Okay. And the vector, when you talk about the vector multiplication and division, again, certain set of rules that you cannot divide these two vectors or you cannot multiply. If you are multiplying that, you have to follow these rules. So vectors operations are pretty different. So there is a difference in the addition of the scalars. Scalars being added using the algebraic addition, whereas vectors are being added with the help of the geometrical addition. When you talk about the dependency on the direction, we know that scalars are independent of the direction, whereas in the vectors, the direction matters. Okay. I hope this thing comes up as with a much clarity. Now, very quick tip that whenever in your exam, it is being asked as a 2 mark question that what are the difference between the scalars and the vectors, then there is a one difference of scalar, like is 1 point for the scalar, 1 point for the vector. Okay, if you have been given a 4-mark question, then it means 2 differences for scalar and 2 differences for vectors. That's how you actually work with the answers in according to your curriculum. Now the next thing that comes up here, that is comparison between distance and displacement. Before we move here, let's just talk about very quickly what is distance. When I talk about distance, the total length of the path, traveled by a body. Okay. For an example, suppose you started from your home, you took 3 meters straight, then you took a turn, moved 2 meters, then 1 meter, then 6 meters, and you reached your school. Okay, so what is the total distance traveled? I'll just add up the length of the path, that is 3 meter plus 2 meter plus 1 meter plus 6 meter. So what it comes out? It is 12 meters. So that is the magnitude of the distance, and distance we have already learned that it is a scalar quantity. It is a scalar quantity. Understood? Okay. And its standard unit, the unit in which we measure it is meters, which has been acceptable all over the world. But what are the other units? Kilometers, centimeters, you could have miles, etc. But standard unit is meter, which is acceptable throughout the world. Then we come up with the quantity, which is displacement. When I talk about the displacement is the shortest distance between initial point and final point. Now, when I talk about the initial point and final point, let's just understand here. When you started from your home, it becomes your initial point. You reached your school, that becomes your final point of that motion. Okay. So when you draw a shortest distance, that is a straight line from home to school. Okay. That represents your displacement. Okay. Now let's just suppose I am observing the motion now from school to home. So school becomes your initial point when you are starting from the school, and home becomes your final point. Then I draw a line again here. Okay. That represents the displacement, though the magnitude could be the same, but the directions are different. One, it is from home to school. Another one is from school to home. So displacement is a vector quantity. Displacement is a vector quantity. Okay. Its standard unit, the unit in which you measure the displacement is meter, and its SI unit, the other units could be kilometers, could be centimeters, could be miles, etc. Now the thing is, can you have a positive displacement, negative displacement, and zero displacement? Yes, the answer is any quantity which is vector, it could be positive, it could be negative, it could be zero. Okay, for an example, let's just understand this, that you started from point A to B and you traveled 50 meters. Here is your distance, and here is, we talk about displacement. So it is 50 meters in the both cases. Now you returned back and you traveled 25 meters more. So here 25 meters. Now what is your distance? Distance is just the addition of the length of the path. So 50 plus 25, that is 75 meters. Whereas what is displacement? Here it becomes, because you have started motion from the point A and you are talking about the motion from A to B and then B to C. So A becomes your initial point and C becomes your final point. So what is the distance between the initial point and final point, that is 25 meters. Correct? Still, from the point A to C, it is still in positive direction, so plus 25. Now, let me just erase it. Now, you come back to the point A, and now you are talking about the whole motion. Your distance becomes 50 plus 50, that is 100 meter. But what is your displacement? 50 positive direction, this one, and then coming back 50 in the negative direction. So that is 0. So your displacement could be 0. Till this point, all the displacements are being positive. Now you moved past your starting point, and let's just say you traveled 10 meters. So what is your distance? 50 meter forward, then coming back to the point A, 50 meter more, and then 10 meter. So it is 110 meters. What is your displacement? That is 10 meters. But in which direction? In the opposite direction, so minus 10. So your displacement could be positive, could be negative, could be 0. Whereas if you look over here, your distance has always been positive and increasing. So distance never decreases with time. So I hope I'm clear, and you can go through the properties of the distance and you can cover up with this. Let's go through this PDF which mentions what are the properties of the displacement. Okay, and I have already covered up the difference between the distance and displacement. Okay, let's just move on to a worked example now. Okay, a car travels 300 meters east, 400 meters west. What is the total distance traveled? You can easily guess. The total distance is 300 meter plus 400 meter, that is 700 meter. Okay, and then what is the displacement? You moved 300 meter east, so 300 meter east is plus 300 meter, and then you moved 400 meter west, so 400 meters. So what is the net displacement that happens? In which direction? That is in the west direction. Okay, so you write 300 meter. And if you still have a confusion, you can write it as 300 meter minus 400 meter. Why minus 400? Because the car is traveling in the west direction. So it comes out to be minus 100 meter. 100 meter becomes the magnitude of the displacement, and negative sign represent that the net displacement is towards west. Okay, so either you write minus 100 meter or you write the answer in this way, 100 meters in west. Now this is your homework. Just take a screenshot of this and can cover it up. I hope you have got an idea what is distance, what is displacement, what is a scalar, what is a vector. In the next class, we are going to talk about how you add vectors. Okay, and then we will move to the speed and velocity too. So if you have understood the concept, please do like, share and subscribe, and follow for more such videos. If you have any queries, drop down in the comment section. We'll reply to it. Thank you so much for attending the session.